What if your electric vehicle's battery percentage went up while you were driving, without stopping, without plugging in, without doing anything at all? That is not science fiction anymore. Right now, in Sweden, Israel, and the United States, governments are spending billions embedding wireless charging technology directly under the road surface. And a handful of electric vehicles can already use it. But here is the part nobody tells you. The technology works, the engineering is proven, the real obstacle has nothing to do with science. Stay with me, because by the end of this video, you will understand exactly how this works, which countries are furthest ahead, and the single problem that could delay everything for a decade. Range anxiety is the number one reason people hesitate to switch to electric vehicles. You plan your entire route around charging stations, you wait 20, 30, sometimes 45 minutes at a fast charger, and if the charger is broken, which happens far more often than the industry admits, you are stranded with no alternative. Wireless charging roads solve every one of those problems in one move. No stop, no cables. The technology is called inductive power transfer, or IPT. Here is the core concept. You take a copper coil, embed it roughly 3 centimeters below the road surface, and run alternating current through it. That creates an oscillating magnetic field above the road. Now, underneath the electric vehicle, bolted to the chassis, there is a second coil called a receiver pad. When the car passes over the transmitter coil buried in the road, the magnetic field induces a current in that receiver pad. That current gets converted to direct current power, which flows straight into the battery. No physical contact, no exposed metal, no sparks, just invisible energy transfer happening through solid tarmac at full highway speed. The efficiency of that transfer sits at around 85 to 90%, meaning if the buried road coil pushes 20 kilowatts of power into the magnetic field, your car captures roughly 17 to 18 kilowatts of it. For context, a standard level 2 home charger delivers about 7 kilowatts. So a single kilometer of active wireless road at highway speed can add somewhere between 5 and 12 miles of range, depending on your vehicle and your driving speed. That is not enough to replace charging entirely, not yet, but that is also not the goal. The goal is to reduce how often you need to stop, and in high traffic corridors like motorways and city bus routes, even a 20% reduction in charging stops changes the entire economics of running electric vehicles at scale. You may ask which companies are leading this. 3 companies. Let us go through each one. Electrion is the furthest ahead in actual live deployment. They completed the world's first public wireless charging road in Tel Aviv, a 600-meter stretch used by an electric bus running a regular passenger route. That bus charges continuously as it drives. It has not needed a single dedicated depot charging session since the system went live. In Sweden, Electron partnered with the Swedish Transport Administration to build a 1.65-kilometer stretch on a public road on Gotland Island. It is the longest wireless charging road in the world, currently open to mixed public traffic. And the operational data coming out of that project is what the entire global industry is watching right now. In the United States, Stellantis and Purdue University opened a wireless charging test section at the Indianapolis Motor Speedway in 2023, 400 meters of active charging surface using technology from a company called Magment, which embeds magnetic particles directly into the concrete rather than using separate modular coil inserts. The U.S. Department of Transportation has since funded 4 additional pilot sites in Michigan and Colorado. Germany announced a 3-kilometer stretch on the A30 Autobahn near the Dutch border, specifically designed for heavy freight trucks. Because trucks follow predictable fixed routes, cover enormous distances every day, and carry the heaviest batteries that are the hardest to charge quickly, the economic case for wireless road charging in freight is the strongest of all vehicle types. The pattern across every single one of these programs is consistent. Commercial buses and trucks come first, consumer passenger cars come second. The reason is straightforward. A bus or truck follows a fixed route. You know exactly where to place the coil to get maximum utilization. A consumer car could go anywhere, and that makes the return on infrastructure investment almost impossible to guarantee. Here is where it gets complicated and where most coverage of this technology stops telling you the complete picture. Installing wireless charging infrastructure costs between 1 and 3 million dollars per kilometer. That is roughly 10 to 15 times the cost of building a standard road. For a 100-kilometer motorway corridor, you are looking at 100 to 300 million dollars just for the wireless charging layer before you have spent anything on the road surface itself. Right now, governments are paying that cost because no private company can recoup that investment at current EV adoption rates. The working business model is to charge vehicles a per kilometer fee for the energy they receive, billed automatically via RFID sensor or the car's onboard connectivity system, the same way a toll road charges you without stopping. Electron's model is to own and operate the road charging infrastructure like a utility company. You pay for the energy you draw from the road. Here is the problem that nobody in this industry wants to discuss in front of a press conference audience: standardization. Right now, Electron's receiver pad does not work with Magment's road coils. The operating frequency used in Germany's Autobahn pilot differs from the one used at Indianapolis. Toyota's receiver geometry does not match the coil spacing optimized for Volkswagen. Every company in this space is building to its own proprietary specification. The International Electrotechnical Commission is working toward a global interoperability standard, so is the Society of Automotive Engineers in the United States. But these processes move slowly by design. The wireless charging standard for stationary home charging pads, a problem that is considerably simpler to solve, took over 7 years from the first formal proposal to a published standard. Until a single agreed global specification exists, no automaker will mass produce vehicles with receiver pads installed as standard equipment. Adding a receiver pad increases vehicle cost and weight. It only makes Electron projects a payback period of 8 to 12 years at moderate traffic volumes on major corridors. The honest counter argument is that for an equivalent budget, you could deploy several hundred 350 kilowatt fast chargers. So, when does this actually reach you? Here is the most honest timeline available, built from current project funding commitments, regulatory pipeline data, and the performance results from active pilot programs. Between 2025 and 2027, expect significant expansion of commercial bus and truck wireless road routes across Europe. Germany, Sweden, Italy, and the Netherlands all have fully funded programs scheduled within this window. Total active wireless road mileage across those four countries is projected to reach between 50 and 100 kilometers by the end of 2027. From 2028 to 2030, if the IEC standardization process lands on its current projected schedule, the first consumer electric vehicles with integrated receiver pads begin shipping from factories. Premium models first, in exactly the same way heated seats began as a luxury differentiator in the 1990s before becoming standard fitment across every segment within a decade. Between 2030 and 2035, major highway corridors in Europe and select high traffic routes in the United States begin full wireless charging infrastructure builds. The European Union has proposed requiring all new major road construction projects to be wireless charging compatible by design from 2035 onward. This is not a technology for most drivers in 2026. It is a technology for most drivers by 2032. And if you are purchasing an electric vehicle today, your next EV has a realistic probability of arriving from the factory with a receiver pad already installed as standard. Wireless charging roads are not a concept, they are not a promise. They are a working technology being installed on public roads right now, carrying real passengers on real routes in real cities today. The engineering problem is solved. The economic model is being stress tested at scale on live infrastructure. The standardization battle is the final obstacle standing between this technology and your driveway, and that battle is being fought in regulatory committees and standards bodies, not in laboratories. The road ahead for wireless charging is being built. Literally, if this gave you a clearer picture of where the technology actually stands, subscribe. Every week, this channel covers the future technologies reshaping electric transport. Without hype, without guesswork, just the clearest and most honest picture of what is actually coming. Next up is vehicle to grid technology. How your parked electric vehicle could start earning you money every single night without you doing anything at all. That video is already live. See you there.